structures, and we are going to start with the topic of data structures and algorithms. Data structures and algorithms. First of all, we actually need to understand what is data structures and what is algorithms. Okay, so let's first of all start talking about data structures. So in your computer, to actually do a lot of things, you need to store data in different ordering. For example, if you see your folder structure, how does your folder structure look like? You have a user folder, then inside the user folder, there can be multiple users, for example, /Sanket, /Sarthak, right? Then in every user folder, you have multiple more folders like documents, music, videos, so on and so forth. Same thing here as well, right? So if you see a folder structure in your computer, in your operating system, then you will realize that this folder structure is a pretty much hierarchical structure, hierarchy-based structure, right? If you see social medias like Facebook, Instagram, right? Then what happens is there's a user, and a user can be connected to another user. That user can be connected to another user, so on and so forth. Right? So let's say this is user U1, U2, U3, U4, U5. If two users are friends, then they are technically connected with each other. This is kind of like a graphical representation, graph representation, and so on. My point being that inside your computer system, to represent different type of data for different use cases, you need to store that data differently. For different problems or different use cases, if you try to optimize your storage, then your overall operations can become fast. For this purpose only, we have the concept of data structures. What are data structures? This is nothing. So if in simple terms I explain, data structures are mental models which helps us, and not just mental model, you can say storage models, storage models which helps us to store data in efficient manner for different use cases. Okay, so what data structure is going to do? It is going to give you kind of like a storage model to organize the data, to store the data in as efficient way as possible for different use cases, right? There will be multiple use cases that we are going to see through one by one, and you will realize that these data structures are helping us for that particular specific use case in efficiently storing the data, and not just efficient storage, but then efficient retrieval of data, efficient addition of data, removal of data, so on and so forth, right? One of the examples of data structures can be arrays. Arrays is one of the data structures because it again gives us a storage model, right? How do you store data in an array, right? Arrays store data in linear order, right? Arrays store data in linear fashion. Although we are going to talk more about it, but what array does is inside your memory, it stores your data in linear fashion, in sequential fashion, right? So if let's say you create an array like this, how it will look like in the memory? Inside the memory, it will look something like this. Inside the memory, it is going to look something like this. That is, one contiguous chunk of the memory has been allocated for this particular array, right? We'll talk more about arrays, but again, I'm saying that you can see this is a linear way of storing the data. Here you have to store the data in kind of like a hierarchy, so on and so forth. So different data structures are there who helps us to store and organize data in efficient manner for different use cases. Few of the examples of data structures are arrays, right? Then linked list, then stacks, queues, trees, etc. Right? These are some examples of data structures. We are going to learn these in very much in depth. Okay, more data structures are there. This is what the meaning of data structure is. Now, what is the meaning of algorithms? Now, algorithm is something very simple. Algorithms. Okay. Now, let's say you wake up in the morning. I'm taking this example from the internet. Like this is very frequently taken example, so I'll just also blindly take it for basic bare minimum understanding. That let's say you wake up in the morning and you want to drink tea. So there's a procedure to prepare the tea, right? You are going to boil up some water, add some tea leaves to it, then boil it up again, then add some milk to it, boil it up again, add some sugar, add some, let's say, extra pieces of spices, so on and so forth, boil it good, and then you will get that tea prepared, right? So preparation of tea has a bunch of defined steps. If you follow them, you'll get a good tea, right? Anything in this world that you see, that you do, has a particular set of defined steps. For example, if you want to drive a car, then you know that there is something called as brake, there is something called as an accelerator, there is something called as a gear, right? If you want to change the gear, you need to press the clutch, right? If you want to give a brake, then you have to press the clutch, and ideally then you should give the brake. There's a steering. If you move it to the right, it will go to the right. If you move to the left, it goes to the left, so on and so forth. There's a whole procedure or whole bunch of steps that people will tell you if they are teaching you how to drive a car, right? So anything that you do in this world has a particular set of defined steps. These defined steps that helps us to achieve a task is called algorithm. Okay, let me give you a very interesting example of algorithms. Okay, let me give you an interesting example of algorithm. So I believe a lot of you guys must have played chess, right? So if I open some plain chess website, or I believe I must be having chess in my system as well. Okay, so this is a chessboard. This is a basic chessboard, right? You can play these kind of chess games online as well. Now let's say if I click on any piece, and let's say I want to move this piece ahead, right? Can you see, based on my piece, the computer responded in some way, right? Then I can take one more piece, right? Or let's say I take one more piece and move it up ahead, right? And the computer responded in a certain way. Then I took one more piece and responded again. So can you see, for every one of my move, the computer is responding, right? So there are some defined steps that the computer is able to take. Apart from that, now using this particular piece that I've highlighted, I can actually take this piece, right? I can actually take this piece. So how it is able to check all of this? How is it able to check all of this? There are defined steps. There's a defined set of rules in chess. Can I say that? For example, this piece I cannot take here. I cannot take this piece here. If I try, it will not let me take it here, or it will not let me take it here. Why? Because there are defined steps. It is able to check that can a piece go to a particular place or not. What are these? These are defined steps, which are nothing but your algorithms, right? If let's say you want to go from one place to another, and you try Google Maps, right? Then Google Maps does some defined set of steps and identifies the shortest path for you. That is what? An algorithm, right? It uses some shortest path algorithms. Okay. More examples. For let's say you are using Snapchat. On Snapchat, you can have filters. How are those filters applied on your images and videos? There's a defined set of steps that your video will be loaded in real time. That on your video there will be one more layer of something that will be added. How that layer will be coded. How that layer will respond based on your facial expressions. It will identify points on your face and then fix those I would say filters on your face, so on and so forth. Everything is a defined set of steps. You make a UPI payment. That's also a defined set of steps that you will first of all choose whom to pay. Then you will enter some amount. Then you will click on the pay button. Then you will enter the PIN. If the PIN is correct, and if you have enough amount on your bank account, then the payment will be deducted. Else, if the PIN was not correct, you will be asked to re-enter your PIN. Else, if your bank account was not having enough amount, you will be asked to choose the right amount that you have in your bank account. So you can see it's a basic set of steps. So algorithms are these kind of steps that are defined steps that will help us to achieve any particular task. That is algorithms. Okay. There are some very famous algorithms that you will learn throughout the course, right? And both of these things together, data structures and algorithms, are going to like I would say, set up your base for computer science fundamentals, also known as DSA, data structures and algorithms. What are data structures? These are mental models that will help you to store data in different fashion for different problems. Algorithms are defined steps that will help you to achieve a particular task. And this is going to be our agenda, that we learn different algorithms, we learn different data structures, and understand their nuances. Is this point making sense? Bunch, I gave examples, right? The chess game, the I would say shortest path algorithm in your maps. I give you examples, right? Make sense, guys?